Okay, let's deal with this problem of these summing up to 0 in any data set. There's two ways statisticians have come up to deal with this. We're going to cover one in this video and the other one in the next couple videos. One way they've dealt with it is this. Looking at these numbers, we already discussed what it means. It means how far you are away from average, but also because some of these are negative and some are positive, it's the direction, right? So a -2 is 2 to the left of average and a +2 is 2 to the right. So what statisticians came up with was a pretty clever solution. They said, well, do we really care if it's left or right of average, or just that it's away from average? And I think that's a pretty clever point. So they said an 83 and a 79 are both 2 away from an average of 81. An 80 and an 82 are both 1 away from an average of 1. So what they said was, let's not just do the deviations, let's take the absolute value of the deviations. Now, in case you've forgotten what absolute value is, don't sweat it. It simply asks a question. When you put a number inside the absolute value signs, it says, how far is that number away from 0? So how far is -1 from 0? Well, it's just 1. How far is 0 from 0? It's not 0. How far is 2 from 0? 2. How far is -2 from 0? Also 2. How far is 1 from 0? 1. So what some students think of this is, and there's nothing wrong with thinking of this like this, is they say, okay, absolute value, if the number's negative, it becomes positive. If it's positive, it stays positive. And if it's 0, it stays 0. And that's an okay way of thinking about it, but it does have a mathematical definition. So then what statisticians said is, this is cool, because if we add these up, they won't cancel and get 0 like we did over here. Because over here, you may have noticed, the 2 and the -2 cancel, and the -1 and the +1 cancel. Well, all those negatives are now positive. So we can actually add up. I'm going to use the summation notation just to keep getting you used to it. If we add up the absolute value of those differences, 1 plus 0 is 1, plus 2 is 3, plus 2 is 5, plus 1 is 6. So what do you do with this? Well, what we wanted to do when we tried to add this column was add these up and average them. Well, now we can. Now we can, because we just added up this column. And that tells us there's 6 total units of variability. And if we average it over the 5 data points, we can get an average variability. And this thing actually has a name. It's called mean absolute deviation. Mean absolute deviation. Mean, because we're going to take an average. Absolute, because of the absolute value. And deviation, because that's what we're measuring. We're measuring the absolute deviation, and we're going to take the mean of it. Mean absolute deviation. It's called MAD, M-A-D, which is a fun little acronym. So for the mean absolute deviation, to calculate that, you just take the number you just got, which is the summation of those absolute value differences, and divide it by the size of your sample. So for this one, I'm going to erase some space here. For this particular one, we already added this up. We figured that was 6. So this is going to be 6 over the sample size of 5, which comes up being 1.2. 1.2 what? What does it mean to have a mean absolute deviation of 1.2? Well, it helps to know what you were adding up in the first place, which I've erased these values here. But when we added these up, that was the distance each one of the data points was from the sample average of 81. When you add up all those distances, you get the sum total of all the deviations. When you divide it by how many there are, you get the average deviation. Speaking of it in slightly more logical terms, Ernie's exams, on average, are 1.2 points away from 81. Remember, his average test score was 81. That means his mean absolute deviation being 1.2 implies that, on average, his exams vary 1.2 points away from that 81. It's a way of describing the variability in his sample data. So on average, he's 1.2 points away from his average. And that might seem a little bit weird, but when you're talking about deviation from the mean, you're talking about it in terms of average. You're talking about it in terms of average. So you have to say the word average twice. On average, Ernie's tests deviate 1.2 points from his average of 81. Isn't that cool? That's mean absolute deviation, or MAD. I'm going to have you calculate Bert's like this in your homework, but all I'll say with it is right now, his is going to have to be larger than 1.2 because his tests are more varied. As we remember, they start down at 61 and go up to 100. Those distances are way greater. So when you calculate Bert's, realize that his mean absolute deviation is going to be much larger. Now, the catch is that mean absolute deviation is pretty awesome. And it's when I ask my students in class to invent a measure of deviation, what's totally rad is they end up inventing this. Because it's such a simple thing, right? I mean, why make them negative and positive? Just make them that distance. This one doesn't get used as much as the one we're going to talk about in the next couple of videos. The next videos, we're going to bring up something called standard deviation. And I think it's called standard deviation because it's pretty much the standard that's used. I could be wrong about that. This one is not used. It's just not used as much, which is unfortunate because, man, it is so incredibly straightforward. But that's okay. We'll deal with standard deviation next.